Imagine a reality where every decision you make, every path you don't take, creates a new timeline, a new version of yourself living out those alternate choices. This is the mind-boggling proposition put forth by the many worlds interpretation of quantum mechanics. The many worlds interpretation of quantum mechanics, first proposed by Hugh Everett in 1957, suggests that every possible outcome of every decision we make spawns a new universe. The idea that we might be living just one of many possible lives is not new. Philosophers and storytellers have long explored the concept of parallel realities. However, MWI moves this concept from the realm of speculation into the domain of theoretical physics. It arises from the perplexing behavior of particles at the quantum level, where the very act of observation seems to influence the outcome. MWI is rooted in the fundamental principles of quantum mechanics, a revolutionary theory that governs the microscopic world of atoms and subatomic particles. Unlike classical physics, which describes a deterministic universe where events unfold predictably, quantum mechanics introduces an inherent randomness and uncertainty. In the quantum realm, particles exist in a state of superposition, meaning they can be in multiple states simultaneously until observed. This bizarre behavior, famously illustrated by Schrödinger's cat thought experiment, is one of the cornerstones of MWI. With an estimated 2 trillion galaxies in the observable universe and potentially infinite, unobservable realities, the notion that multiple versions of ourselves exist is no longer just science fiction, it is a legitimate theoretical possibility. To grasp the mind-bending implications of the many worlds interpretation, or MWI, we must first delve into the strange and counterintuitive world of quantum mechanics, a realm where the rules of reality as we know it are turned upside down. This branch of physics, developed in the early 20th century, focuses on the principle of superposition, famously demonstrated in the double-slit experiment, which shows that particles can exist in multiple states until observed. This principle defies our classical understanding of how objects should behave. Unlike objects in our macroscopic world which exist in a single definite state at any given time, quantum particles can exist in multiple states simultaneously. This duality is not just theoretical but has been observed in numerous experiments. This means a particle can be in 2 places at once, spinning in opposite directions simultaneously, or even both alive and dead, as in the famous thought experiment involving Schrödinger's cat. This paradox challenges our very perception of reality. Another key principle is entanglement, a phenomenon where 2 or more particles become linked, even when separated by vast distances. This connection is instantaneous and seemingly defies the speed of light. 2 entangled particles can instantly affect each other regardless of distance, a phenomenon that Albert Einstein called spooky action at a distance. This interconnectedness allows for instantaneous correlations between their states, regardless of the spatial separation. It's as if the particles share information faster than the speed of light. Measuring the state of one entangled particle instantly determines the state of the other, no matter how far apart they are. This phenomenon has been experimentally verified and continues to baffle scientists. These bizarre quantum phenomena, while experimentally verified, defy common sense and challenge our classical intuition. They force us to rethink the very nature of reality. Yet, they form the very bedrock upon which the many worlds interpretation is built. This interpretation offers a radical view of the universe. MWI suggests that superposition and entanglement are not just mathematical quirks, but reflect a profound truth about the nature of reality. It posits that every quantum event spawns a new universe. In essence, MWI argues that the universe doesn't choose which outcome becomes real upon measurement. Instead, every possible outcome of a quantum event unfolds in a separate, parallel universe. This means there are countless versions of reality, each as real as the one we experience. Each universe within this vast multiverse represents a different timeline or a different path that reality could have taken. The implications of this are both fascinating and mind-boggling, opening up endless possibilities for what reality truly is. The concept of parallel universes, while rooted in theoretical physics, has fascinated both scientists and the general public for decades. Often spills over into popular culture, inspiring countless books, movies, and TV shows that explore the idea of alternate realities, sparking speculation about the nature of reality and our place within it. Some people believe that certain unexplained phenomena, such as déjà vu and out-of-body experiences, might offer glimpses into these alternate realities. Déjà vu, the eerie feeling of having already experienced a present situation, has long puzzled scientists and philosophers alike. While various explanations have been proposed, ranging from neurological glitches to subconscious memory tricks, the mystery remains unsolved. The experience of déjà vu, reported by 60 to 80% of people at least once in their lifetime, is often cited as potential evidence of parallel universes. Some speculate that déjà vu might be a signpost from a parallel life. Could this feeling of familiarity stem from a brief overlap or intersection with an alternate timeline where we lived out a similar experience? Similarly, around 10% of people claim to have had an out-of-body experience, where they describe floating outside their physical body, often observing events from a detached perspective. The out-of-body experiences, characterized by the sensation of floating outside one's physical body, have been attributed to everything from near-death experiences to altered states of consciousness. Some proponents of MWI suggest that these experiences might involve a temporary detachment of consciousness, allowing it to briefly perceive reality from the perspective of another self in a parallel universe. While these interpretations remain highly speculative, they offer a tantalizing glimpse into what might be possible. Similarly, near-death experiences, reported by 10 to 20% of those who have come close to dying, often involve visions of a different realm, encounters with deceased loved ones, or a tunnel of light leading to another plane of existence. Could these be transitions between parallel lives? They highlight the profound implications of MWI, blurring the lines between science fiction and theoretical physics. Could seemingly paranormal phenomena be explained by the existence of parallel dimensions and the interaction between different versions of ourselves? While current scientific understanding cannot definitively answer these questions, the ongoing research in quantum mechanics and consciousness studies continues to push the boundaries of what we know. The possibility, however remote, is tantalizing. Perhaps as we delve deeper into the mysteries of quantum mechanics and the nature of consciousness, we will uncover new insights that could revolutionize our understanding of reality itself. We'll gain a clearer understanding of these enigmatic experiences and their potential connection to the multiverse. The journey to uncover these truths is just beginning, and the future holds endless possibilities. Synchronicity, meaningful coincidences, or interdimensional connections. Swiss psychiatrist Carl Jung coined the term synchronicity to describe meaningful coincidences that seem to defy the laws of probability. These coincidences often leave us in awe, wondering if there is more to our reality than meets the eye. These events, often imbued with profound personal significance, appear to be more than just random occurrences, suggesting an underlying interconnectedness within the fabric of reality. They make us question the nature of chance and destiny. Jung believed that synchronicity revealed a hidden order in the universe, operating beyond the realm of cause and effect. This hidden order might be the key to understanding the deeper connections that bind us all. Could synchronicity, with its uncanny timing and improbable connections, be another hint of parallel realities at play? These moments often feel like glimpses into a larger, more complex universe. Some proponents of the many worlds interpretation suggest that what we perceive as meaningful coincidences might be glimpses into parallel timelines, where our lives have unfolded differently. This theory opens up fascinating possibilities about the nature of our existence. These synchronicities, then, could be viewed as points of intersection or resonance between these alternate realities. They might be the moments where different versions of our lives briefly align. Imagine a scenario where you think of a long-lost friend, only to bump into them the very next day. Such encounters often feel too significant to be mere chance. While this could be dismissed as mere coincidence, the many worlds interpretation offers an alternative explanation. A brief alignment with a parallel timeline where you remained in contact with that friend all along. This idea challenges our perception of reality. While this interpretation remains speculative, it highlights the profound philosophical implications of entertaining the possibility of parallel universes. It invites us to rethink the nature of reality and our place within it. If our lives are but one thread in a vast tapestry of alternate realities, then the boundaries of self, choice, and chance take on a whole new meaning. This perspective can profoundly alter how we view our experiences and the world around us. String theory and hidden dimensions, a peek beyond our reality. Venturing further into the realm of theoretical physics, we encounter string theory, an elegant yet complex framework that attempts to unify all forces of nature. According to this theory, the universe may contain up to 11 dimensions, some of which could be home to parallel realities. String theory posits that the fundamental building blocks of the universe are not point-like particles, but rather tiny, vibrating strings of energy. One of the most intriguing aspects of string theory is its requirement for extra spatial dimensions beyond the three we experience in our everyday lives. These hidden dimensions, curled up and compactified at incredibly small scales, are thought to govern the behavior of strings and, consequently, the fundamental forces of nature. The existence of these extra dimensions, while still hypothetical, has profound implications for the possibility of parallel universes. Some models of string theory suggest that our three-dimensional universe might be embedded within a higher dimensional space, much like a sheet of paper existing within a three-dimensional room. Within this higher dimensional bulk, there could be other three-dimensional universes, or branes as they are called in string theory, each representing a different reality. Cosmologists have sought physical evidence of parallel universes through anomalies in the cosmic microwave background radiation. In 2010, researchers analyzing data from NASA's Wilkinson Microwave Anisotropy Probe identified unexplained cold spots in the cosmic radiation that some theorists believe could be the result of collisions between universes. While currently beyond our technological capabilities, some physicists speculate that high-energy collisions in particle accelerators like the Large Hadron Collider might offer a glimpse into these hidden dimensions. The search for dark matter, which makes up approximately 85% of the universe's total mass, has led some scientists to theorize that it could be a sign of hidden dimensions. If dark matter interacts with our universe through gravity alone, it might exist within a parallel realm, exerting influence without being directly observable. Future advancements in particle physics could bring us closer to uncovering the truth about these hidden realities. The Mandela Effect is another phenomenon that has fueled speculation about parallel lives. Named after the widespread false memory that Nelson Mandela died in prison in the 1980s when he actually passed away in 2013. This effect involves large groups of people recalling historical events or details differently from recorded history. The pursuit of understanding parallel lives is not just an academic exercise, it challenges how we view our decisions, our relationships, and our very sense of purpose. If all possible versions of our existence play out somewhere, what does that mean for the significance of our individual choices? The implications stretch far beyond theoretical physics, touching on philosophy, spirituality, and even the way we define our personal narratives. Perhaps one day, scientific advancements will allow us to not only theorize about parallel realities, but also interact with them in ways that are currently beyond our imagination. Technological advancements in quantum computing may provide new insights into the nature of parallel worlds. Quantum computers, which rely on superposition and entanglement, can process information in multiple states simultaneously. Some theorists speculate that these computers could one day tap into parallel realities, extracting data from alternate timelines. While this remains speculative, the rapid progress in quantum research suggests that our understanding of reality is still in its infancy.